All right, so in this next section, we're going to prove some complex identities or properties. So in the syllabus, it says you have to know how to prove these. So in general, if you're just given like just say Z1 and Z2, pretty much you just rename them. So like just say let Z1 be A plus BI or just say X plus IY. It doesn't really matter, whatever you want. As long as Z1 and Z2 are different complex numbers in standard form. So like there'll be proofs where you need to use mod arg form so that you'll know because like you need to prove an argument. So that's obvious to use mod arg form, but we'll look at that in the next video. So just say for this one, we have to prove that the modulus of Z1 times Z2 is the same as the modulus of Z1 times the modulus of Z2 separately. So pretty much, yeah. So normally just let Z1 equal A plus BI and Z2 equals C plus DI. And then from here on, it's pretty much just algebra. So yeah, let's do this one. So the first thing, let's just find Z1 times Z2 first. So yeah, we'll just expand and then we'll put real and imaginary bits together again, as usual. All right, so remember we need to find the modulus of Z1 times Z2. So let's just find the modulus of this. So same as what we did last lesson. So square root and then the square of the real bit plus the square of the imaginary bit. And then we're going to expand and simplify. And as you can see, the minus 2abcd and the plus 2abcd cancel out, which is nice. So yeah, so if you get stuck here, just move on to the right-hand side and then just start mucking around with the right-hand side. But since I know what we need to prove, I'm just going to end up factorizing this part into two pairs. But yeah, if you ever get stuck, just start working the other side and see if you can get something to equal this wherever you're up to. So yeah, so for this one, I'm going to factor out the a squared. So I'm going to put the a squared c squared plus a squared d squared together. So that give me a squared and then c squared plus d squared. And if I do a similar thing for the b squares, I'm going to get c squared plus d squared. Then that gives us a squared plus b squared times c squared plus d squared. All right, so now I'm going to move on to the right-hand side. So we know the right-hand side is Z1 times Z2, the modulus of them. All right, so Z1 is A plus BI. So that means the modulus of that is square root A squared plus B squared. And then the modulus of Z2 is just C squared, square root of C squared plus D squared. And then put these two together. We can see they both end up the same. So therefore, the modulus of Z1 times Z2 equals the modulus of Z1 times the modulus of Z2. So yeah, this section is just mostly just algebra. So there's a few more questions at the bottom here. Have a go at these, and then just unpause the video and the answers should appear. All right, so here are the answers for A and B. See, as long as you remember that when you find the conjugate, it's just the real bit and you change the sign, so just make the imaginary bit, just change the sign of the imaginary bit. So yeah, have a go at the next two, and then I'll show the answers, and then that'll be the end of the video. So yeah, these two should be pretty quick. All right, so there are the last two answers. So yeah, so technically in every question, in every new proof, you should write let z equal a plus bi, or like z1 equals a plus b, or z2 equals um, c plus di.